Good day, everyone. Welcome to Calcumind. Today, we'll be looking at statistics, under which we'll be taking the introduction to probability. Now, what is probability? Probability is the likelihood that an event will occur. It is represented by a number between 0 and 1 inclusive. If it is 0, it means that there is no likelihood of the event occurring, which implies that it is impossible. If it is 1, it means that the likelihood of the event occurring is certain, meaning that the event is definitely going to occur. Now, there's what we call a probability scale. What is a probability scale? A probability scale is a number line from 0 to 1 that measures the likelihood of an event ranging from impossible to certain. So, probability scale. We have our number line, and on one end, we have 0, marking impossible or unlikely to occur. And on the other end of the number line, we have 1, which means that this is certainty that the event is going to occur. In the middle, we have 0.5. This presents an even chance of an event occurring. To the left, we have 0.25 as an example. To the right, we have 0.75. Now, to the right of the even chance of the event occurring, this is the even chance, the likely region. While to the left of the even chance, we have the unlikely region. This implies that whenever you have a probability that is less than 0.5 or that lies between 0 to less than 0.5, it is unlikely that the event is going to occur. And whenever you have a probability that lies between greater than 0.5 to 1, it is likely that the event is going to occur. Okay, next up, we are going to be looking at sample space under the terminologies involved in probability. Now, what is a sample space? This is the set of all possible outcomes or results of a random experiment. Now, we have that sample space is denoted as S. It acts as the foundation for a set of probability containing every individual outcome or sample point. Sample spaces can be finite or continuous. Now, examples of this we have for a coin toss. We have that the sample space S is equal to the sample points, heads, and tails. What this implies is simply the outcomes that we have whenever we carry out the experiment, the random experiment of tossing a coin. When you toss a coin, you have two possibilities, which are the heads and the tails, which makes up the sample space. Then, for a dice roll, we have that the sample space is equal to 1, 2, 3, 4, 5, 6. Because for a fair six-sided die, it has 6 faces, which have the numbers 1, 2, 3, 4, 5, and 6, which give us the sample space for a fair die. For 2 dice, we have the sample space will be ranging from 1, 2, 3, 4. For 2 dice, when we toss 2 dice simultaneously, we have 1, 1 as one sample point, we have 1, 2 as another sample point, we have 1, 3 down to 6, 6. Now, for this sample space for 2 dice, it is important to have it in mind that there will be 36 sample points because from 1, 1 down to 6, 6, we have 36 different outcomes for the 2 dice when you toss the 2 dice. Now, we'll be looking at the sample space for 2 coins. For 2 coins, we have that the sample space, we have 2 heads, a head and a tail and a head, and 2 tails. Up next, we'll be looking at an example under probability. We are going to be taking an example under probability. Now the question says, a fair coin is tossed. What is the probability of a head? Now to answer this question, solution, firstly, we look at the sample space like we earlier discussed for a coin. We have that the sample space for a coin is head and tail, meaning that the total sample size is 2 points. Now, the formula for finding probability, they say what's the probability of head? We say P of H is equal to N of H all over N of S, where N of H is the total favorable outcome for this experiment, and N of S is the total number of outcomes which is the sample points for this sample S. So N of S, we have 2 sample points, heads and tails, is equal to 2. While N of H, the favorable outcome, which is what we are asked to find, the probability of a head. So how many heads do we have here? We have 1. So it's equal to 1. That implies that the probability of getting a head is equal to 1 over 2. Our next question says, a die is rolled. What is the probability of getting a 3? So like what we did for the previous one, we say probability of getting a 3, P of 3, is equal to N of 3, which is the favorable outcome for getting a 3, all over N of S, which is the sample space, and which is the the number of total outcomes. The number of total outcomes, or the total number of possible outcomes. So we have that the probability of getting a 3 is equal to, what is the favorable outcome for getting a 3? From the sample space, we can look at it and we know that a 3 appears only once on a die. So we have that that is 1, divided by the total number of possible outcomes. And for a 6-sided die, we have that the total possible outcomes ranges from 1, 2, 3, 4, 5, and 6, meaning that the total number of possible outcomes is 6. So the probability of getting a 3 when a 6-sided die is rolled once is 1 over 6. Our third question says, a bag has 3 red and 2 blue balls. What is the probability of picking red? So we have the probability of picking red is equal to the total number of favorable outcomes for red divided by the total number of possible outcomes, which is the total sample space, where the total number of possible outcomes for red, they have told us that there are 3 red balls, is equal to 3. And the total number of possible outcomes, the total number of balls we have, which is 3 plus 2, is equal to 5. Therefore, the probability of picking red is equal to 3 over 5. Thank you for watching the video. Please do well to like, share, and subscribe. And please remember to join the community in the description below and comment your thoughts to us underneath. Thank you very much.